In this lesson, you will write and graph linear equations in slope-intercept form, and we'll also model real-world data of equations in slope-intercept form. And what that is an equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. So this is what the equation looks like, and this equation would be good to write in your notes so that you have it. We're going to use it for the whole lesson today. A constant function is a linear function in the form of y equals b. So remember, b is the y-intercept, so this is going to be a horizontal line, and the y-intercept is going to tell you where it is horizontal. So let me show you some examples of those. We need to write an equation of the line whose slope is 3/4 and whose y-intercept is -2. What's great about this is we don't need the graph. Here's why. This is the form that we're going to be using, slope-intercept form. M is the slope, so you just plug that in, so 3/4 x, and the y-intercept is -2. So I make it a -2 because it's a -2. If it was a positive y-intercept, then you would have a plus here. And that's why this has a plus here, because it could be either a positive or a negative. So this would be the slope-intercept form of this line whose slope is 3/4 and whose y-intercept is -2. Why don't you try the example in your notes? Now we have a graph. So the first thing we're going to do is solve for y, because we want to get it into slope-intercept form. So we're going to subtract 3x, and we have 2y is equal to -3x plus 6. Now we're going to divide by 2, and we have y equals -3/2 x plus 3. Now this equation tells me two things. I know the slope now is -3/2, and I know the y-intercept is a +3. So this is how we're going to graph. Find the y-intercept first. 1, 2, 3. Now we do the slope. Remember what slope is? Rise over run. So what we're going to do is fall 3, run 2. Fall 3, run 2. Fall 3, run 2. And then you would connect these with your ruler and go from there. Why don't you try the example in your notes? This equation is in constant form, y equals b. And so this is a horizontal line at -3. So 1, 2, 3 down. And so that means every coordinate is going to be at -3 because it's a horizontal line, just y equals. So try the constant example in your notes. Write the slope-intercept form of this line here. So we need to know two things from the graph. We need to find the slope and we need to find the y-intercept, because our y is going to stay y and our x is going to stay x. So we just need to find that slope we can put in here and that y-intercept to put in here. So the y-intercept is right here. That is a +1. So I know it's going to be +1. And then to find the slope, I look for the next point, which is right here. And this is a fall 1, run 3. So my slope is -1/3 because it's a fall 1, run 3. So I plug that in here, and now I have the slope-intercept form of the line. So you try the example in your notes. The real-world example we're going to work with today is sports. In 1997, about 2.6 million girls competed in high school sports. The number of girls competing in high school sports has increased by an average of 0.06 million per year since 1997. So that's going to be a slope, because this is a rate of change, and a rate of change is the same as slope. It's a change in quantity over time. So this is a 0.06. We're going to leave it as 0.06, but remember this is million per year. So this is representing million per year. And then the y-intercept, what we're going to use as the y-intercept is 2.6, because that's 2.6 million girls in the year 1997, and that's going to be the starting of our graph here is in 1997. See how this axis here says years since 1997? So 1997 is here, and that's going to be right here at 26, or 2.6, excuse me. So we'll have that be 2.6, 1.6, we'll go a scale to match here. So up here we have a y-intercept of 2.6. Our equation would be 0.06x plus 2.6, because this is our slope or rate of change, and this is our y-intercept. And then what we have to do here is we have to figure out how many girls in the year 2017. Well, how many years is that since 1997? Find that real quick. So we're going to do 20 for our x, because this is going to be per year. So we're going to take 0.06 times 20 and then add 2.6. So I'll do that on my calculator real quick here. So we get a total of 3.8. So remember, this is in millions. So we're going to say 3.8 million girls will be competing in the year 2017. And then I can graph that. 3.6 was about right here, so 3.8 would be right here. And then I would have array, because we're not going to really be concerned about the left side of this graph. So try the real world example in your notes.